Chemistry fans, we are going to get into the Unit 5 exam solutions right now. This is dealing with the redox reactions. So let's jump right into it. Let me share my screen with you so we can make haste on this, try and get you out the door quicker to a better grade for the third 9 weeks. Okay. I have cut off all of the rules. I will refer to them as we go along, how I know what these individual charges are, but just for times or for space saving purposes. Okay, so what I'm going to do is I'm going to try and figure out what are my rules that apply to these elements. Well, the first is that oxygens are always a -2. There are some certain scenarios where they are diatomic, that they might be as part of a peroxide polyatomic. This is not one of those scenarios. So I've got a total of -18 for all of the oxygens. I have another rule that says that all of the elements in the second column are going to have a charge of +2. That's going to give me a +6, meaning the difference, because all this has to equal up to be 0, another one of our rules. So this is going to be an X 12, meaning that each one of these has got to be a +6, because +6 and +6 gives you the +12. 12 and 6 gives you 18. -18 gives me the 0. So +6 is my value for each of those chlorines. What is the oxidation state for each atom in iodine, elemental iodine? Well, that means it's I2. Regardless, even if you would have guessed it, if it said that it was elemental, it's going to have a charge of 0. Each atom in this one is going to have the 0 charge. Okay, moving on, number 3. In this scenario, we've got a polyatomic ion, so its total charge is not going to be equal to 0. In fact, it's going to be equal to +2. Now, the same charge is being held true for the oxygens as it was in number 1. This is a -6 value here. We now have established that there is a different rule, though, for hydrogens. They are always going to be a +1, so that's going to give me a +3. This does not need to equal 0, so it's not going to be a +3 for the nitrogen. It's going to be, what we need it to end up being is more than that. So I'm going to have a +5, because if I have that, that's going to give me a +8 here. -6 would be the +2. So my oxygen needs to have the +5 charge. All right. Number 4. Now, which elements are oxidized, which ones are reduced? So we need to establish that elements by themselves have a charge of 0. I need to establish that halogens have the -1 charge. Well, that didn't change. So I know that the chlorines are out of the running. My hydrogen's +1, so I know it's out of the running. But that means that this bromine is going to go from a 0 to a -1. So 0 to -1 means it's gaining an electron. That means it is being reduced. Okay, so the element that is being reduced is the Br. Now, I'm not asking for what the material is. I'm asking for what the element is that's being reduced. That gives us now either the niobium or the sulfur that's left over. Well, over here on the right, I've got 2 chlorines. That's a -2 total. So that means that this one had to be a +2 for the niobium. On the left side, it's -2 and +2. So the niobium did not change its charge. It's this sulfur that goes from a -2 to a 0. Well, that means it lost 2 electrons. So it's going to lose 2 of its electrons. Whoops, I've got this on the wrong side. So it needs to add an electron over here. This means that it is losing 2 electrons. In that process of losing electrons, that means that it is going to be the oxidized material. So the sulfur is what is oxidized. Okay, so that takes care of questions 3, 4. Let's jump to question number 5. And in this one, what role does chlorine play? Well, we don't know until we start figuring out. Well, oh, and it's unfortunate that this one got cut off the way it did. It needs to be on its own line. This whole thing needs to be on its own line. Anyway, the chlorine over here has a -1 charge, and over here, again, a -1. So it did not change its charge. The term that comes to these types of materials are called spectator ions. And I understand that you may have known what its role was defining it. You had to come up with the correct term. Warned you about that one in advance, that it was going to be on there. Spectator ions. It was actually in the review, named out for question number 5. You just had to look at the review for that one. Number 6, which substance is the reducing agent? Okay, so here we are again, having this scenario where we got to figure out what the charges are. Well, the iron goes from an Fe plus 2 to an Fe plus 3. That means it has lost an electron. When you lose electrons, that is oxidizing, which means that this material on the left is the reducing agent. So it is the entire material, the Fe plus 2, because I don't know if you know it's this one or it's this one that lost the electron. So you must be very specific. You must state Fe plus 2, because it is the entire substance and it's not an element that we're talking about. It's the substance, which is the agent, not the element that is being oxidized or reduced. You must be able to distinguish betwixt those. All right, moving on now to the difficult part, number 7. There's a whole bunch of series of steps that we have to go through to balance a redox reaction. So let's jump into it. First off, we need to separate these into half reactions. So I'm going to separate this into S2O3 minus 2 producing S4O6. My second half reaction is going to be the MnO4 minus 1 producing Mn plus 2. Okay. First step is that you must balance elements that are not oxygen or hydrogen. So I will do that by simply adding a 2 in front. When I do that, that's going to give me 4 sulfurs. That's also going to give me the problem that's going to balance out the oxygens. So I actually don't need to add any oxygens or sulfurs to that one. Down below, I've got MNs. They're already balanced. It's just the oxygens. We'll pick that one up in just a second. Okay, so being that I don't need to balance any hydrogens or oxygens on the first half reaction, what that means is, I'll circle these so you don't get confused. What that means then is I'm going to jump down to the second half reaction and I'm going to add 4 waters. That's how you balance oxygens, is by adding waters. Once you've added the 4 waters, the 4 oxygens, you've now changed the number of hydrogens. So I actually have to add 8 hydrogen ions to the left. Well, in doing that process, I've now changed the charges on these reactions. So now I'm going to balance not only reaction 1, but reaction 2. So let's total up what my charges are. The total charge here is plus 4. Down below, the total charge is plus 7 and plus 2. So how did I get plus 7? It's 8 minus 1. On the right side, it's a plus 2. Up top, it's 2 times the S2O3, but there are a minus 2 charge, so I just simply double that. Ooh, it's minus 2, sorry. It's minus 2. So that's a minus 4 there. All right, so now how do I balance? Well, it's not that you need to balance the number of charges to 0, it's that you just got to make sure that you balance the electrons so that the charges are the same. So I will put 4 electrons on the right side of the first half reaction. On the left, I'm going to put 5 electrons, because if I have 7 minus 5, that's going to give me a plus 2, and that's going to balance out both sides of this half reaction. Okay, now I'm all balanced out. Everything is balanced. In theory, we could start the process of balancing or summing up all this, except for my number of electrons are not equal. So I need to bring those to a common multiple. I will multiply everything by top by 5, everything down below by 4, so they both have 20 electrons. That's the lowest common multiple between 4 and 5. Now I'm going to distribute that 5 out. So I'm going to have 10 of the S2O3 minus 2s. I'm going to have 20 electrons. I'm going to have 32 hydrogens. I'm going to have 4 MnO4 minus 1s. I'm going to have 4 Mn plus 2s. I'm going to have 16 waters. I'm going to have 5 S4O6s and 20 electrons. The last step is to cancel out common terms. The only common terms you're going to have are the electrons. This is your final answer then. Okay, I'm going to move on now to question number 8. Same exact process. Let's see where the mistakes lie. Okay. So half reactions, easy to see. So I'm going to split this up for the iodines and for the chromiums. All right. So I will start with one of the easy ones. I'm just going to put the chromium, and it's going to turn into chromium plus 3. And then the second half reaction, 5IO6 produces IO3 minus 1. That should have a parentheses around it. If that threw you off, I am very sorry for that. That should not have been like that. I should have put parentheses around that for you. Okay, so the chromium, there's nothing to balance on this one. So all I got to do is add 3 electrons, and now that one is balanced. So stinking simple. Down below, my iodines are already balanced. So I'm going to balance out my water. So I'm going to put, my oxygen. So I'm going to add 3 waters. Well, in that process, I actually add 6 hydrogens. Well, I already have 5 of them, so I only need to add 1 hydrogen over here on the left. Now, let's see what charges we have here. I've got -1. I have over on this side -1, and over here I have +1. So that means I need to add 2 electrons to get them both equal to the same charge, -1. Well, in doing so, now we've set up a problem in that both of these half reactions don't have the same number of electrons. I need to find a common multiple. The lowest common multiples are 2 and 3s. I distribute those 2 and 3s throughout, and so I get what my final answer is being 2 CRs plus 6 electrons plus 3 hydrogens, 3 of this H5IO6, producing 2 chromium ions plus 6 electrons plus 3 IO3 iodates and 9 waters. Okay, so at this point, I don't have anything that can cancel out except for my electrons. Everything else stays. This is your final answer. All right, hopefully you see where maybe some of your mistakes may have come about, and you were able to explain them. You're able to give me definitions. You're able to give me proof that you understand the content, not that you just can copy my answers. That's not the task at hand. The task is to prove that you understand where your mistakes are, that you can understand the content, that if you had another chance at this, you'd get a 100 on this. So thank you so much for your time. Hopefully this will help you get through the process. Bye-bye.